All right, this is our first lecture on section 5.4, finding linear equations. Our objectives are to find an equation of a line by using the slope and a point. The y-intercept point is the one that we're going to use, and I want you to note that I do have a fundamental difference of opinion with your author about this, and finding an equation of a line using the point-slope form. So first off, we are going to be reminding ourselves that the equation of a line can be written in three different forms. First, that we learned the slope-intercept form, and then we introduced the general form just very recently, and finally we're going to learn our last form of the line, the point-slope form. And each way has its drawbacks and its benefits. The slope-intercept form is our most informative because it's a way of getting the slope and the y-intercept very directly and leads to a graph quite easily. We're going to start out by writing equations using the slope-intercept form, which was the one that we've already used to write some equations of lines. In fact, prior to section 4.2, we were already using this method. So we're going to start out with that slope-intercept form, and we're going to end up with using our point-slope form after we introduce that. Now I want to go over here very briefly and just review something about some special types of lines with you. So first off, we have our horizontal, our y equals lines, so y equals some b. Remember that the ordered pairs on these lines always have the same same y coordinates. The b's are always there, whatever that is. And the x's can be anything under the sun. The slope of a horizontal line is always equal to 0. And then the vertical lines are x equals lines. X equals a, and on these all of the x coordinates are always exactly the same, and the y's are anything under the sun. The slopes of these are undefined, so remember x equals, these are vertical, and our y equals, those are horizontal. And with that said, we're going to go ahead and we're going to get into our topic, which is writing equations of lines. So our first thing that we need to realize is that there's three scenarios under which we could use a slope-intercept form to write the equation of a line quite easily. First of all, somebody hands us on a silver platter the slope and the y-intercept, or maybe they give us the y-intercept not quite on a silver platter, but they give it to us as an ordered pair. And when we do see it as an ordered pair, remember that the x must be equal to 0, and that's what tells us that it is the y-intercept point. Another way is that we might be given 2 points, in which case we'll have to find the slope, and then the 1 point we'll recognize again as the y-intercept because the x will be equal to 0. And finally, we could have the line drawn for us, a visual interpretation of it, and it must be very clear that the y-intercept is an integer ordered pair because we don't want to be guessing about that. So, slope-intercept form, remember again, is y equals mx plus b. Remember that we've also seen function notation, so we could see it as the y being replaced by the f of x symbol. So here are some scenario 1 examples. First off, if we're given the slope and the y-intercept handed to them on the silver platter, we're going to write y is equal to the slope times my x and then plus my b. And there couldn't be anything easier than that. Now, this next one, this is why I went over those special circumstances. When you see that the slope is equal to 0, this is going to tell you that you have a horizontal line. And when you're told you have a horizontal line, you know that whatever the y coordinate is going to be your answer. So you say y is equal to 2/3. That is the easiest way to write an equation for a horizontal line and the one that we want to get used to. Now, likewise, for a vertical line, when we see the slope is equal to undefined, that tells us that we have a vertical line, and therefore we should be paying attention to the x coordinate here in order to write the equation x equals -1/2. Now, unlike with the horizontal line, this is the only way you can write an equation for a vertical line, because vertical lines aren't functions and they don't fit into slope-intercept form because they aren't a function, which slope-intercept form is a function. I'll see you in the next section.